We are live. So, hey guys, welcome back to the channel. Today, I start the second episode of Akamai's Gaming Masterclass. Today's topic is improve the player experience with a responsive UI. And today, I have with me Akamai's Pavel, Despot, Senior
Recording in
Product Manager,
progress.
Senior Product Marketing Manager, and Jonathan Singer, Senior Industry Marketing Manager, for a perspective of the mobile games industry and how gaming organizations can navigate this maze of architecture to win on performance and security. I will let Jonathan do the introduction for today's topic. So Jonathan, the stage is yours. Go ahead.
Thank you so much. And Nikhil, again, thank you for being such a gracious host. We're having a lot of fun doing this and working together. It's fantastic. So thank you again. And I'll get out of the way. I'll come back for the Q&A later, but I'd like to again introduce Pavel. And Pavel, I know you've got a presentation that you'd like to share to start with. And so come on and bring it online, and then we'll come back at the end for the Q&A and we'll have a conversation. I will let folks know that when we do the Q&A at the end, you'll be able to put your questions up in YouTube. I know that there are some folks that are going to be on Zoom as well, so we'll be monitoring that too. And so we're looking forward to that conversation. Pavel, take it away.
Great. Thank you all. The obligatory, can you all see my screen, I hope? And as Nikhil and Jonathan said today, we're going to be talking about improving the player experience. And specifically around that, there are a lot of player experiences that there are to discuss. These are three of them that we could look at. The first is the download experience. So whether you're going through a portal or you're downloading the game through some other mechanism, we want to consider how long it takes the user to get the game and install it. That's one aspect of user experience. The next one is the actual gameplay traffic. Now, of course, that supposes that this is an online game. The preponderance of them today are, but from that aspect, we want to make sure that once the user has finished that first step and they've downloaded it and they've installed it, now any online gameplay traffic, we want to make sure works so that we keep the user engaged, keep the user using the game and coming back. The third piece that we should consider, and this is probably the one that's most overlooked, is the experience and the administrative kind of functions. Think of think of most applications. Think of the website where you register, the mobile app where you share accomplishments, all those types of functions. That's what we're going to focus on today, not the gameplay traffic itself, not the downloads, but the actual touch points where a user has to interact, whether it's for account creation, sharing, messaging, that part of the application. So like I said, that's oftentimes overlooked, and that can be a big part of the user experience, whether I go in and reclaim any points or so forth. And that's what we want to make sure that we're not forgetting. So to put this in a context a little bit, this is the part that we're talking about. Regardless of the device, whether it's mobile, whether it's an app, whether it's a site, whether it's a console, we're talking about these type of generic functions that everyone implements. Most people implement some part of that for their game. And the reason we want to pay attention to the performance of these particular functions is because in a lot of ways they're just as important as the gameplay, as the download and the download. Remember, we're actually in here trying to decrease the friction to get people to use the games, to get people to continue to interact with the applications. And the way we think of that, like we said, usually it's make sure the download's fast, make sure the gameplay is good. But if we want more usage of these other interactive parts of the game, we need to pay attention to the performance of those as well, because like we've seen from commerce and years in the CDN and performance industry, people, especially these days, are very much less inclined to wait for a page to load or a transaction to complete. they'll just go away. And that's what we're really trying to prevent here when we focus on the user experience. So how can we think about, moving a little technically, how can we think about all the content, all the requests that we have to support for our game? One way to think of it is in these three areas. So the first is static content. Static content is anything that you can think of, whether it's a game binary, whether it's an image, a video, an asset for a landing page, the CSS and JavaScript that make up some of these mobile sites. Static content, even though these things seem different, we can group them together and do a lot to improve the overall performance of the services that we just talked about. There's a lot we can do with static content. A second type of content and service is going to be delivering HTML. Think of the services that you've built to create that landing page or that web view so the user can log in, so the user can access social mechanisms. That's the HTML piece. And then the last piece to think about is APIs. APIs on our platform make up somewhere over 60 to 70% of all requests. That's pretty common because APIs, you can think of, these would be your login APIs, these would be your search, messaging, all these functions that you implement that are outside the static content in HTML. So these are the three types of content. And now that we know the three types of content, we can start looking at how to improve the performance of each of those portions of our page, with, again, the goal of making sure that we have that best user experience so the users stay connected and stay engaged with the application. So let's start with static content. And static content, we can think about, like we said, this could be anywhere from static page assets like JavaScript, images, CSS, to the actual downloads. And what we're looking at here are some settings that and some features that we should always make use of for caching. I've included the Akamai screenshots for anyone that wants to configure this in the Akamai platform. But even those aside, just remember, these are best practices that you should be doing to help this first type of content, which is static content. So the first thing is caching. Not really a surprise, CDNs caching, it is really the best way to improve performance, distribute your content, and actually save some money on your cloud egress. Because if you're caching it, you're not traversing any AWS or Azure or whomever else and incurring egress costs. So we can't stress how important caching is. And we have to remember that there's a lot we can do there. Specifically, we want to increase TTLs. TTLs are time to live. And basically what that means is by increasing that, the CDN, whichever one that you're using, is going to come to your infrastructure less frequently to say, hey, is there a newer version of this? Now, the first thing that we usually hear from people is, well, I don't want to make my TTLs too big, because then if I push out another release, I update my JavaScript, I update something, then it's in cache. Well, that's fine. You can purge very quickly and integrate that into your CI/CD. So that used to be a concern among folks making cache TTLs too long, but given how quickly we could purge today, we've seen that really go away. So make sure you increase your TTL to the extent reasonable. 7 days is a good start. If you have longer, you can certainly do it. The other thing when caching, and again, this varies a little bit by what platform you're using to do this, is make sure you're using the right query strings when you identify an object. What I mean by that is most CDNs will give you the option to include or not include the query string to uniquely identify an object. So object.js with a query string may or may not be different, which may mean it may need to be cached differently. So make sure that you've got that setting. You want to use the least specific setting you can use. Number 3, extension matches. Make sure your file extensions are covered. Make sure everything you want to cache, whether you're doing it by file extension or not, make sure you are caching everything. Don't just take the defaults. A lot of times there's additional content types and extensions that can be cached. So make sure if you're using anything, make sure you've got everything listed so you're not caching things that you should be. And then lastly, and you'll hear this as a constant repeat, measure. Measure your offload, measure your content types. In Akamai, you can do this by just assigning a CP code. But what we really want to do if we're going to be serious about improving performance, especially with caching, is we want to be able to track our changes. So definitely look at when you make changes, as you're tuning it, make sure you're pulling out the offload content specifically and looking at that metric. Because like we said, that's ultimately going to drive improved performance and save you some costs on egress. In addition to caching, there are a number of things that we can do to adapt the content. What do I mean by adapt the content? Well, first of all, let's take SVGs, for example. SVGs, software vector graphics, are images, but they are transmitted as text. So what we mean by content adaptation for SVGs is we can compress that like we would a CSS or JS to decrease the bytes and improve the speed. So don't forget your SVGs when we're talking about compression. The other thing to remember with content adaptation is images. We see images anywhere from 20 to 40 bytes of the total site. So compressing those, minimizing the bytes for images, of course, without impacting quality, can really save a good chunk of the bytes that we're transmitting and again, improve the performance. So you have things like browser specific images, new formats, WebP, JPEG XR. You should consider using those, either automating, having the CDN automate that adaptation of those image types, or do it on your side. But you can really save a lot of bytes by using those optimal image formats, and sometimes even scaling for mobile devices. For example, if you have very large assets, if you have a responsive site or web view, that's great. It'll rescale that image back, that big image that you're using on the desktop, to the mobile, but you're still transmitting all those bytes. It'd be a lot better if instead of sending that big hero image and you're letting the client download that big image, rescale it, and then display it. It'd be a lot better if you could, before you sent the image, just send the right one, the smallest one. And those are some features you should look at for static content, like image optimization and that type of thing. Of course, the last piece is always measure your bytes, measure your changes, see what works, see what's the most effective. And there's a few different ways to do that. Really, this is all the things that you can do for, again, broadly speaking, with static content. Cache everything you can. And then for images, for things that you can adapt and save bytes and save download time, do that before you send it to the client, rather than downloading that 4 meg hero image and letting, maybe a responsive library on the client resize it to the appropriate size. The other thing that makes up a web page is the HTML. So obviously the HTML refers to some of these static assets that we've been talking about. And we just talked about how we can make the static assets distributed with caching, how we can optimize the format based on the device, based on the bandwidth. But for all that to be downloaded and work, the first thing that has to happen is, again, assuming this isn't just an API endpoint, but for a portal or even a web view, there's HTML that needs to be downloaded. And that's generally what we call rendering. Apologies if a large part of folks already know this. But in that process of rendering, what happens is the client, be it a browser or a mobile app, is going to get the HTML. and then go through that HTML and look for resources, look for the images, look for the CSS, look for the JavaScript, and so forth. And as it relates to performance, we should really consider, and we should take a look at what JavaScripts we're downloading. As a lot of you might know, JavaScript is blocking. So when a browser or client gets the HTML, it's going to kind of stop what it's doing while it gets and executes the JavaScript. And the reason we're talking about that in the context of performance is because if the browser stops and waiting to go get a JavaScript and then waits to get it, what does it mean if the browser can't get it or it's slow, the JavaScript? Even if it's third party, right? There's now issues because that page, your page, might just be sitting there waiting for some JavaScript to load and execute, and that's delaying the whole thing. So when it comes to the overall performance of the site, we look at things like JavaScript execution. There are a lot of tools, Script Manager and Impulse from Akamai are a few of them, but you really want to look at the scripts that you're using, and particularly ones that are blocking and are something called a single point of failure, because we saw recently with some of the Facebook outages, and they happen all the time. That's just the most recent one. Those scripts can impact performance and actually even take the site down. Just because you've done all this work to cache your content, to optimize your any database reads and optimize your code, we're still at the mercy on the client side of these kind of JavaScript. So that's definitely one place to look at, and there's a few tools to both monitor and mitigate some of that. And then while on the topic of rendering and third-party scripts, there are rel tags, and I think we'll have this presentation, rel tags in your HTML that you can either add manually or have the Edge add them. And they are used for third-party domains to help the browser anticipate, or help the browser start doing some DNS and TCP work before you need to speed up the overall process. And again, that's to help with getting those JavaScripts and getting those resources in, so that when the browser does have to render, it doesn't take as long. And of course, I did promise you that I was going to harp on measuring, and I'll be true to my word, I hope. There's a lot of different ways to measure a user experience. You will hear all sorts of things like time to first byte, connection time, and there is indeed value in looking at many different metrics. I like to liken it, though, to the overall user experience to a restaurant. If I go in somewhere and I am immediately greeted right away and seated, great user experience, right? I'm happy about that. I'd much rather would have done that than wait 20 minutes to not have a table, all that good stuff. But then if I get seated right away and my food takes 2 hours to show up, is it still a great user experience? And the reason I share that example is because a lot of those time to first byte metrics are really analogous to, okay, well, we got you seated right away. Right, time to first byte is you got the first byte of the HTML or the API right away. And there's a bunch of things you can do for that, which is great. It's a good start, but you don't have your food yet, right? You don't have the rest of the HTML. You don't have the rest of the API call. So as a result, Google and the industry have come up with what they call core web vitals. There's the link. And these are metrics that are meant to more closely relate to our user experience, the total user experience, right? Not how long it took us to get seated when we went out for dinner, how long it took us to get seated, get the order taken, how right the food was, how quickly we got out, how clean everything. That's kind of the analogy of what these metrics are trying to do. And like I said, you can find more info on there at this website. This is Google's official site with tools and everything. But really, as you look through these, you'll notice that these metrics are more focused around the user. Meaning time to first byte, the user has no idea when the first byte comes in, right? I mean, unless you're doing Wireshark or something. So those are those kinds of metrics. What Google is ranking pages on and the industry is looking at are metrics like these that are directly tied to the user, like largest contentful paint. That's simply when does the user see the biggest part of the screen draw? Because that's going to be an indicator to users like, oh, okay, this is working. Things are being downloaded. First input delay, right? When can I start actually clicking on things? Where can I start typing in my username, my password? Probably like most of you, you're going to try to start doing that before the page even loads. And when it doesn't, I get a little bit cranky. So these are the kind of metrics that we should be looking at. Some links there to tools that can give you these metrics. But these are really, as we talk about performance, these are really the right holistic metrics to look at. And it's not to say that other metrics aren't indicative of problems and should be used to debug. But if we're really talking about how is our user doing? Is our user happy? Is our user having a responsive page? These are what the industry is currently settled on in terms of metrics. And we talk about HTML, just as a quick reminder, again, I probably don't need to tell anyone on the call this. A lot of mobile apps, especially if you're using web views, it's really just HTML in the background. It's not all that different from a web browser, aside, of course, from some of the capabilities in the JavaScript engine you might have. But as it relates to performance, they're very, very, very similar. So number three, we talked about static content. We want to cache. We want to adapt. We talked about HTML. We want to make sure that any scripts that are being called aren't causing issues. We want to optimize that rendering and we want to measure it correctly. The last piece that we talked about is APIs. And this is an interesting one because a lot of times our customers say, oh, okay, yeah, it's APIs. I'm not going to cache it. Well, it's not entirely true. You can cache APIs. That is an entirely different topic for possibly a different day. So we'll leave that aside for the moment. But as it relates to just sheer performance, APIs can frequently be cached, but they're also important, especially login type APIs, synchronous services. And what I mean by that is, think of my login, right? If I go to my app, my website, I put in my username, that login endpoint, whatever you're using, that's synchronous in that until that login completes, I, as a user, am just sitting there waiting for it to go, approved or not. Those are the type of APIs, specifically the synchronous ones, that it's important to think about performance. The reason is, in that synchronous API, as a login, for example, if that takes 2 seconds for me to complete that login process, I'm literally waiting 2 seconds. I'm doing nothing else except going, okay, come on. Whereas if you have maybe an API that's updating a message counter, providing some other ancillary non-synchronous service on one of these apps, is performance important? Outright performance? Well, maybe. It certainly depends on your use case. But what I'm suggesting is, when we look at just flat out, how can I make this faster? And you want to prioritize, because I'm betting most people have more than one thing to prioritize. Those are where you should start, the synchronous API calls. And specifically, what we're looking at here is a test that we ran a few weeks ago. And we are testing a 50 kilobyte GET request. The origin or the infrastructure happens to be living in AWS US East. We tested it globally. And what we tested was using Catchpoint, a synthetic testing tool. If you folks are familiar, there's a bunch in the market, Rigor, Dynatrace, and so forth. What we tested was the average response time, the total time it took to download that 50 kilobit object globally. And that's what we see at this top green line here. So over these few days that we ran the test, globally from US East, this 50 kilobyte GET took, we can call it 610 milliseconds. Global median is the metric we're looking at. with the edge and with the routing, without caching, that same global response time we can get down to, for that 50 kilobyte object, we can get down to about 270. And these are pretty typical results. The point here being is that if, let's go back to our previous example, we were doing this for this login service. If we just applied nothing else other than this API acceleration, we could decrease our login response, the time a user clicks for at least that API to happen, globally median by over half. And that's the kind of thing of the judicious kind of application of where to apply the acceleration that can really make a big difference. Again, measuring, the way to measure, the best way to measure is with some real user monitoring tool. And all that means, for those of you that might not be familiar, real user monitoring is a type of measuring that is done by injecting a tiny little piece of JavaScript in the HTML. It has to be HTML. And that JavaScript will take measurements of everything that happened on the page. The core web vitals, how long the APIs took. And the reason I'm suggesting using a real user measurement tool for performance rather than synthetic testing, or in addition to synthetic testing or testing against your own, load testing against your own services, is those are very good tests that test your services. But the user is experiencing an environment that you can't control that middle mile because it's the internet, where they have a lot of things going on their device. There's a lot of network issues. So really, if you want to know, if you're serious about user performance and measuring what users are actually experiencing and why they're leaving, real user monitoring is the best way to do it when applicable. And of course, that requires HTML, but it is the absolute objective source of truth with respect to what's happening on the client side, right? And really, the best way we should go measuring on a day-to-day basis. So that's how we make those API calls faster. But if we're going to focus on the users, which we always should, we have to keep in mind that there's another aspect to service that user, and that is routing. Now, this depends a little bit on how much infrastructure you've had and how you've built the apps and where you've deployed to. But most applications and most services will have at least some redundancy, will have maybe at least two regions, and a lot of them will have a lot more. And what happens there is, as you start building out, you get these very piecemeal ways of trying to route across services, load balance, active standby, and you get these inefficient routing that gets a lot worse the more services you have, again, whether you're using cube clusters or EC2 or whatever. And that increase in the total number of origins they have to use is going to impact routing, right? It's going to make it more difficult. And the reason we care about inefficient routing is because A, it can hurt our performance, and B, it can decrease availability. Hurting our performance, for example, if we have two origins, let's say one's in Mumbai and one, let's say you put in US East. If I mistakenly route folks from Bangalore to US East, it works. You know, it's another instance, but it's going to be a lot slower, right? It's going to be, the performance is going to be suboptimal. So where we route and how we route, even though most people don't think of load balancing as a very exciting topic, or certainly not one related to performance, that's a really good example. And we've seen people doing that. Even folks going in with percentage load balancing, right? That's a common way to do it and say, okay, well, I've got Mumbai and US East, great, I'll just go 50-50. Well, that means 50% of your European users might be getting routed to Mumbai, and 50% of your, India users might be routed to the US. It's inefficient. While it works, you're leaving performance on the table. And similarly, when there's a failure, if you don't have efficient routing and that kind of stuff, what you're going to do is you're going to have decreased availability because you're not rerouting. So what does it look like? Well, let's take a look back at our fake service here. This is maybe a mobile app, maybe it's a mobile site. We have a login, we have an account, we can share things, of course, a store. And on the left, it might look like that. But on the right, it might look something like this. And I did abstract the actual compute layers, use your imagination, whether, and insert your favorite virtualization or container technology for each. But the point is simply that as a user, when I make a request to log in or to search or to purchase something, I'll have to be directed to one of these instances. The instance to which I'm directed should take into consideration performance, not just is it active or some percentage, right? That is certainly a way to do it. It's not the best way from a performance standpoint. So like we talked about, if we're using this example and this user happens to be in Karnataka, when they go to log in, that API request, that post of their credentials or however you're doing your API, should be sent to the VPC in Mumbai, not the one in US East. So that's what we talk about routing. There's a few different ways to do that. The best way is to do it at the edge before you get to the data center, right? That's hugely important. I can't stress that enough. Because if we take this example, if we put our geo load balancing in the data center, we've just messed up what we were trying to do. Because what we were trying to do, remember, is we were trying to get this particular user here, right, in our example, this guy, to the right data center. And in this case, let's say this one is, this one here is Bangalore, and this one is US East. If I put my load balancing, my global load balancing in the data center, what happens to my user here in Bangalore? He went to US East to say, oh, no, just kidding. You really belong in Bangalore and Tokyo or EU or some other data center. So that's why we really want to do, this at the edge rather than doing it in the data center, right? It's going to get us to the right origin set and get us there get us there the first time rather than having to bounce around. The other piece that we talked about, sorry, just get rid of some of that ink. The other piece that we talked about is failure. So what we've done now for APIs is great. We're getting the right people to the right origin. But sometimes instances fail. Sometimes there is an issue at the VPC. A lot of things can go wrong. So what do we do there? Well, in that case, this also works because let's say our instance before happened to, this one right here happened to just have an issue, right? Whatever that issue might be, this guy had an issue and now it's dead. The way to, again, from a user experience standpoint, when that fails, we really don't want to kind of send an error back to here, right? You don't want to see your login failed, there was an error, please try again. Nobody likes that. Again, for the purposes of user experience, but not necessarily for speed here, what we do when that fails is instead of responding to the client with that failure, we retry it in a different place, right? This is another aspect of, and that other place, right, is an equivalent instance of the service. Maybe this is the one in some other data center, maybe it's in Japan, or wherever you like to put it. And the reason we do this is so that the user doesn't see that, hey, something happened And then, your failover happens and they try again, and you have to type in your password and you always get it wrong because my thumbs are too big. So we mentioned this in the context of user experience. It's not absolute speed like we mentioned earlier with caching static content and accelerating APIs, but it's still an important aspect of user experience, because again, if we could hide any errors that happen on this side and retry them without this side having to do anything, again, whether it's for login or search, that's just going to be a better user experience. Admittedly, not from the it's faster standpoint, because now we're not talking about making things faster. We're talking about making it smoother and easier for the user so they don't have to retype things, so they don't have to see failures. And that's the other facet of user experience. So a quick, how is this all done? It's actually not all that challenging, and especially for anyone using a CDN, a lot of that functionality that you need to accomplish everything we've talked about is already in Akamai. It's just a matter of setting it up. So what would we want from this routing engine? Because we just spent a lot of time talking about routing, especially around APIs. Some of them are stateful, some of them aren't, some of them are cacheable, some aren't. So these are some ways in general just to think about the performance and availability, like load balancing for performance and availability. And it's specifically for APIs because caching, we don't have a lot of these issues. There's no such thing as a stateful image.jpg. You get it from wherever you get it. So that's why we're focusing on APIs here. They are more complex. There's certain intricacies that we need to deal with. So what should we do? We need to be able to route across any cloud and any zone. That's so that everyone can have the capability and the flexibility to deploy the compute and storage wherever you want. We want to look at the endpoints that are most critical to our user experience. We talked about login, search is another one, transactional. Anything that's synchronous is probably a good endpoint to at least start prioritizing for performance. Once you do that, you can then start looking at tracking which one's available, implementing retry and failover, so that we can, again, from a not speed user experience, but from a user experience, I want to hide any issues. That's what we want to accomplish with there. And lastly, we're seeing this more and more is, especially during peaky times with this season coming up, we can also or should also consider prioritizing certain methods, certain API endpoints in the case of a spike. So what I mean by that is, let's use, again, this example on the left of a simple, kind of game landing page. If I am truly under heavy load, what I can do for a quick short-term fix is prioritize certain traffic to certain endpoints, things like login, transactional endpoints, and deprioritize, even drop if necessary, things like message updates or screen updates. So that's something we should look for when we're thinking about how to do this routing and how to go through things. And the way that looks, again, this is very specific with Akamai, but this is how that would look, right? Each one of these gray boxes is, I'm sure you've heard, the edge servers, and that is where we implement all the features that we talked about, but it's in just one place. So you go in, you configure your security, which again is a whole separate topic, but worthy of mention. And then based on that individual request, each individual request from each individual subscriber, we'll go through this flow here through in an edge server. And like we saw, if it's cacheable, great, we'll retrieve it from cache. If we need to optimize the content for any reason, we can do that. If it's an API, we can do all our auth. We can then do the routing that we talked about and the global load balancing, then forward it to anywhere you might need it to go. In this case, again, as an example, we have 3 availability zones, but the point is, whether you have 1 or 2 or 3 or 10, the number of origin endpoints, the load balancing, all still holds. What we found though is the more VPCs people go into, and the more regions, the more complex you start having to play with, firewall managers and the like. So that's when a lot of this consolidation in a single edge platform really, really makes a bigger difference even. That was really it. Love to take any questions, comments from anyone.
All right, so Pavel, first, thanks so much for that. That was a pretty in-depth presentation, and we'll, as the kind of questions start coming in through the chat, I know that we'll open it back up on YouTube in a few minutes, but I want to lead with a question here, and that is, we are speaking to a crowd here that is, a game developer crowd, and I would imagine that in some ways this presentation was a little bit of culture shock for them, right? Because we are talking about the player experience from a very different perspective. And where do you think, folks who are really focused, again, from the gaming side of things, what's the pivot that they need to make in thinking where everything that you just talked about really matches up with their world?
Sure. So I think, especially a game developer, it's a huge world. And it is what we were talking about here was one aspect of it. And this was the part where, not the downloading, right? Not the gameplay, but that one piece where I'm interacting with not necessarily the game, but with your service, with your messaging, with your whatever. So I think that the pivot there is not a big one. It's, look, developing games, keeping them interactive, keeping them responsive is a huge, huge challenge with a whole different set of skills and whatnot, and problems that you have to solve. This is just one of them. So what I mean is, of course, game developers are going to focus on the gameplay, are going to focus on the story, going to focus on the usability, as you should. And this is just another piece of that that happens to be very HTML-y. But I would argue that if you look at it, maybe aside from the gameplay, under the covers, all the game developers are using HTML, they're using APIs. So the pivot, I guess, point is, it's not a much of a pivot. It's a more, oh yeah, that's underneath the covers there. And we have all this tech and all these ways to address problems with HTML that all commerce and all these other people have been doing for 10 years. And oh wait, a part of our bigger thing that we have to fix is this, so we can just borrow all the stuff that they've been doing. It certainly doesn't fix everything, right? You still have, as a gaming developer, you have to worry about gameplay, you have to worry about the device power, there's all this stuff that you want to code, but there's not enough battery, there's not enough graphics, there's not enough anything ever. This, I think, the change is more, just remember there's HTML in there, and that's at least one thing you don't have to worry about as much, because that's been a lot more sussed out because it's been going on for quite some time in all these other verticals.
Yeah, perfect. And thank you for digging in there. And I want to remind folks, especially those who joined 2 weeks ago, this is a lot of what I was talking about, which is that, so I'm almost 40 years old. I think I'm allowed to say that. And so when I was a kid, video games, right, it was a cartridge, popped it in, or it was, discs I installed on my PC. And that was, but the experience now is this constantly connected experience. And so what we at Akamai are trying to, when we think about games, we think about the player experience, we're thinking about everything beyond the core gameplay, right? So you've got everything that you think of as a video game, and then you've got all of the microservices around to it that connect into it, that in a lot of ways determine how the player experiences getting into and out of your game and interacting with it. And when those fall down, when those are slow, when they're overloaded, the player experience really suffers. And I think that this was our real deep dive into that that piece of it that I had promised last time.
On that
so
point,
thank you again.
If I may, I apologize. We were in recently, because I think that's a huge point about what a game is. And it was echoed recently in a user group that we had. And the head of this one gaming company, you've heard of it, his point was, and I think it's it's exactly what you were saying, Jonathan, is and his point was, if our job was still popping cartridges, or if gaming was still popping cartridges into consoles, none of us would be here. And his point was that the gameplay is one thing, and it's important, right? I mean, it's probably the most important. And since beyond that, right, as we've evolved, we've changed from going out to the store and buying cartridges or CDs to downloading them. So great. Okay, that changed. And that was pretty easy, right? We had the scale. We've already been doing terabytes of stuff. So that wasn't too terribly much of a challenge. But the gaming experience, my experience, right? Whether it's Horizon 5 or, some casual thing I download, that experience is connected. There isn't a single, even the offline, quote unquote, offline apps are connecting, are giving me some aspect of that experience. I mean, if it's not the gameplay, some aspect of that gaming experience is interactive, it is social, it is connected. And as soon as it is, its performance impacts my experience, because if it's slow and crappy, I'm just going to leave. Even if the gameplay is fine, if my login takes 10 seconds, I don't have time for this in between meetings when I'm trying to get a quick new score. So that's, I think, the point that I've heard from a few and varied gaming companies is, yeah, that's absolutely right. It's not just to download and forget. It's like, okay, I got the download fast, I'm done, let me go work on the new version. It's download, go back to the site, even in games, not the gameplay. But if you're going in the game, if you're sharing something, if you're trying to say, hey, look, join me, right? That's usually an API call. If that's slow and poking around, that's going to impact the game. So I think I won't beat this one to death too much more, but the notion that a game is just this piece of software that runs locally, and that's how I get my gaming experience, is antiquated and at least a decade old.
Yeah, absolutely. All right, so not to linger too much longer on that topic, we've covered like why this relates and why this is important to player experience. The next thing that I want to talk about, still kind of in the vein of the culture of game developers, is that we keep talking about the edge, we keep talking about CDNs and how you should run your APIs through the edge. But again, everyone listening to this, they're all cloud native developers, right? They think in terms of cloud providers and that specific tool set. And so what is the difference in thinking about what we've been talking about from a cloud perspective to an edge perspective? What's the pivot there in thinking?
Sure. So I think the pivot there is that, well, the first one, I don't think it's a huge pivot. The notion, or how this is generally done, of using a CDN, for those that might not be familiar or aware, it's not a library or a code type of integration. This happens at HTTP level. So my point in saying that, without how to onboard, going a whole lesson on how to onboard, is there's nothing in the application that needs to change, or I need to think of necessarily different about, okay, if I'm going to code this library with or without CDN, it should be the same. You shouldn't really be doing anything differently. The pivot, I think, is more in how are we going to test? Because when you do have any additional layer in your application, you should include that in your testing regime, right? Whether it's a CDN or like an Nginx proxy that you just deployed in front of your, you should test, you should have that as part of your testing. And that's one pivot, or one change that I think people should make, is, okay, now that if I do have a CDN, I do want to test that in staging, and there's staging testing and all that good stuff. But you do want to make sure that everything plays nice, It usually does, but again, we all want to test. The other pivot I think that should be made is to not think about necessarily different functions. We're not suggesting here with like the load balancing, you can do that with like an API gateway, maybe like an Nginx or like a node kind of instance. So, and that's how I think a lot of folks, at least in my experience, have been thinking about it today. Developers, architects, like, oh yeah, no, we'll put a proxy in there and then we'll load balance across the clusters locally and it'll be great. The load balancer will go to each ingress controller and life is fantastic. That's how people think now. I think the pivot isn't that, no, now you don't need that function. You do need load balancing. It's hugely important. The pivot is just don't put it in your data center. Move it out to where the cache is, move it out to where your firewall already is, move it out to where your image optimization already is. That's the pivot. It's not that you don't need load balancing anymore. It's that you shouldn't put it in a centralized location, because then as you have more locations, what happens? You have more load balancers that you have to manage, right? You have more complex scheme and everything. Move all that stuff out to the edge, move the caching, move all that. That's the second pivot is, remember, we're not saying new functions. We're saying reconsider where you put them for the sake of performance and management.
Okay. Yeah, I think that makes a lot of sense. There's one thing that you said that I want to dig into, and actually you can bring down the question screen so that people can see us a little bit bigger. Sure. If you want. Yeah. No worries. Assuming that doesn't blow everything up. All right, cool. We're all still there. Awesome. You never know. No. So the one little point that you said that I want to dive into, especially for folks here who, again, are more heavily on the game dev side, is you mentioned something about code changes in there and how like this is more of a toggle than a code change. What do you really mean by that for those who haven't had a chance to interact with these tools?
Sure. So and things, there's a lot of different solutions out there. Right now, the way the edge is always, or Akamai's edge anyway, is always meant to work is the application code is where it is, the clusters are where they are, your static content is where it is, and we're just grabbing the traffic. We're kind of intercepting that user's request and then looking at it before we even send it to the API, the S3 bucket, the whatever. And the way that's done is just through DNS. Not just DNS, but it's done through DNS. In that, for the load balancing, for the application firewall, whatever functions that we talked about, the code, whatever endpoints that you've built are still going to get requests. They are going to look no different than requests coming from the client. So from that perspective, there's nothing that needs to be changed, right, to get requests from Akamai. Well, how does the user get into Akamai? Well, that's just DNS. So if you look at any site, www.akamai.com included, you'll notice that it's the usual method of making a DNS change. That gets the traffic to Akamai, to the edge. And then based on the rules and everything, we forward it on. So to the point of no code change, no, this is literally happening at a traffic level. And of course, we deal with TLS, but it's happening at a traffic level. So if you really look at the application, it doesn't know that this is Akamai, these are users. So that's what I mean by not having to make any code changes. You don't have to go into the HTML and create rel tags. You don't have to go into your backend and zip a bunch of images. You change your DNS, it runs through, and then we'll forward the request and proxy things as appropriate. Now, to clear up, despite that, yes, you should still test, like we said, but there isn't a specific code change or anything that needs to be made. This is all just happening at DNS and layer 3.
Yeah, no, that's great clarification. So I actually want to turn it over to Nikhil, because Nikhil, we've been talking a lot, but this is your channel, and you're the one who actually develops games here. We just help. And so I want to ask you, throughout this, have we raised any points that are of particular interest to you that you want to discuss? Are there any questions you might have? We want to hear your thoughts as well.
Sure. So first of all, Pavel, I think that was a wonderful session. I will just pin myself because I have to do it manually since I'm on mute on the other chat. So there are some, really great points that I took from the conversation. I really enjoyed the restaurant example. I thought that was particularly very much fun. And personally, I'm not much of a server-side guy, so I was surprised that you could actually cache APIs, because up until this point of time, I was just aware of caching your images, videos, and whatnot. So could you just highlight a little bit on the API caching front and how it can be helpful for the users? Let's say like a particular use case for this can be your accounts that are hosted and the logins information that you can use to log into your account. So is there anything particular that one should keep in mind for API caching?
100%. So if it's a post, please be careful.
Okay.
You can cache posts. It is possible. The reason I open with that is because generally, right, if you look at the RFCs, posts are supposed to be the verb that you use to change data on the server. So there are valid-ish use cases where you want to do that from cache. They tend to be workarounds, has been my experience, right? So that aside, right, let's look at where caching would be most useful, which is reusable content, which would be more of a get type of scenario, right? Where I'm just getting some information and that's why it'd be mostly reusable, right? It's unlikely that posting to the same URL would be, but so let's look at those. What are some things we might want to get? Well, a lot of list type functions, statuses, if there's like UGC stuff, those kinds of updates. And if we look at the APIs that are getting, or mostly gets, not a hard and fast rule, but a rule of thumb, mostly gets and are reusable, those could be really interesting to cache. I'll give you one example where we did such a thing. Think weather API. So we did two things there, and I'll focus on the caching, but first we actually adjusted they passed the Latin long in a query string, and it went to like 10 digits. And if you know anything about GPS, that's like millimeters of space, which is completely ridiculous. So number one, for the APIs, we mentioned the query string, we lopped off the query string, right? Because minus 73.1256 is going to have the same weather as minus 73.1. So we did that. But then secondly, we actually started caching those for 15, 20 seconds a pop. The reason was that was not going to change that much in that time period, right? For them, that was the time period. I believe they actually ended up extending it. But number two, the reason they did that is, I don't know which weather apps you guys use, but I find them all painfully slow. I don't know why it takes 20 minutes for one of them to like show me that it's like, 10 degrees outside, but it does. And the reason it does is the database dip's expensive. Especially these folks that have all these like different weather stations that they're trying to do. So that lookup, when I go, what's the weather in Medford, Massachusetts, is actually pretty expensive on their side. And it doesn't change, and it's pretty reusable given the geographic population. So, alarm bells just came up in our head, like, wait a minute, that's a perfect one to cache. And it was relatively easy because they were just using RESTful API and they just responded back some JSON. So that's a perfect example on reads, on expensive reads that can be reusable. Totally go for it, like high scores. Now maybe high scores, if somebody just beats it, you can always purge as well. So that's not an issue. The other time to think about it is during high peak, high peak, but also using GraphQL. So GraphQL especially is pretty expensive. It's not hugely deployed. We're seeing it pick up a lot more. But GraphQL tends to be more expensive from a compute standpoint, a lookup standpoint. And the body, right, that XML that you post can can change a lot. So for that, especially for folks using that, given how expensive it is and how mutable the post is, that's where we've seen people start to cache a lot more. In other words, you can go in and normalize and canonicalize that post body, which kind of sets you up for the query, cache the query or portions of the query, and then offload the whole notion. And it's going back to the same one as before, right? You don't want to do that database step, especially with GraphQL, because that could be kind of heavy. So those are probably the two most common API caching use cases. And again, if you cache posts, you can do it, but please don't say Pavel from Akamai told you when people get logged in, because that's all joking aside. Very careful if you do that, because you can do it. It's totally fine. It's just HTTP, but especially with logins. So that's the last caveat that I'll offer there.
Awesome. So there's one question coming from Amarjeet. It's a scorecard or leaderboard APIs for real money games. That's the number one API caching use case for Indian gaming companies right now. So that's also something that you can cache. That's just an addition to your wealth of information that you just. There was also one particular point that you mentioned was about real user monitoring. So what are the exact factors to monitor, and what are the factors to look for when you are monitoring when you are doing this real user monitoring?
Sure. So the first thing I would look at is, because I in a previous life I came from an ops background. So the first thing I'd look at is errors. What's dying on the page? Why is it dying? What's timing out? And the reason I would start there is because I'm always worried about the P95 users that have the bad experience, right? Because they're gone, right? They're leaving. So I always go by my brain always goes first, like the worst possible experience. So what is that user experience? Errors on the page, scripts that didn't execute, scripts that timed out that may have blocked something, URLs, especially that gave me back errors. I want to find those, because those users they didn't even have a slow experience. They didn't have any experience. So those are the first ones I immediately zoom into. And then look for patterns of, is there a geo? Is there a browser, right? That's the nice thing about real user monitoring. It can tell you when the browser, Chrome 95 or whatever the next release is comes out, you can see, did my errors spike on that new browser? Versus synthetics, you can't, right? You're just kind of testing it and you hope it's somewhat duplicates what the users see. So that, I think, is the first thing to look at RUM. Is errors, script timeouts, any 4xx or 5xx. And then the second thing to look at is just trending metrics for user performance. Point in time is great, but also look at trends, and especially correlate those core vitals to changes to either the CDN, changes to the backend, because that's what's going to let you go back and say, oh, wait a minute, something happened, right? Last Tuesday, we've seen our largest contentful paint time go down. When you can correlate that to your, whatever your CIC or whatever your workflow is, and most RUM tools, Impulse included, you can annotate like, okay, new config pushed out here. I think that's a huge thing. So look at those metrics. So look at errors. Look at errors constantly. Number two, look at the core vitals, because those are the industry accepted ways to measure, and look at it in time frame mapped to what you're making changes to your infrastructure, because that's what's going to help you be like, oh, look, we pushed out version X last Wednesday, and look, Thursday morning we saw X metric go down for this browser or something. That's a really good way to look at it, and to integrate real user data into operations. And it doesn't have to be like a
little bit of lag on my end due to the streaming side, but be rest assured that this is a recorded session, and it'll be on the YouTube site, so you can revisit this once all of this is fixed. So this is being constantly streamed to the YouTube platform. Perhaps maybe Akamai can help get this fixed for YouTube. But the question is asked by a user on YouTube is, what is perhaps the best way to manage traffic in servers? Is this something that you can shed some light on?
Sure. So I think, so traffic management, I would implement, again, I would implement as much of it as possible at the edge. And the way I would do that is I would first kind of map out where all my infrastructure is, right? Where are my data center, where are my regions, what services do I have? And then I would look at, kind of bucket them into what we talked about. Static content, great, those are easy, right? Traffic management there is really just cache the heck out of it and, you know, go as high TTLs as you can and done. For API, especially for API stuff, I would keep in mind that you have the ability to direct transparently to the user, right? I don't mean, when I say direct, I don't mean redirect via an HTTP 301, 302, anything like that. I mean, user connects to edge. You have the ability to direct wherever you want to go. So in real time, you can actually, to the point of traffic management, you can switch from origin A to origin B if origin A is being overloaded. So that's one aspect of traffic management, remembering that you can swing traffic over transparently without the user ever seeing anything. Just by saying, okay, this is the new origin, or I want this percentage or that percentage. The other thing I would look at traffic management, the other thing I would consider when thinking about traffic management is feedback. So and a lot of folks don't use this today, and I think I understand why, or I have a theory, is normally when you're doing load balancing, you say percentage or pick the fastest, closest data center or region, or you do something like that, and you do a failover. What I don't see a lot of folks take advantage of is the function where instead of just saying 50-50 or 30-70 or geo here, geo there, there is a function in many load balancers, Akamai included, to give feedback. So instead of just saying, yes, I'm alive, right, which is usually what a health check is, it just says, okay, yep, you could still send traffic to this endpoint. Yep, still alive, 200, okay, great. What a lot of folks aren't using, and I think would be good for that traffic management, is instead of just saying, yes, I'm alive, you can actually provide a weight of how busy that particular origin endpoint is. The idea behind doing that is that once you say to the traffic management service, hey, okay, I'm alive, but I'm at 90% and my target is 70, you can have that edge kind of automatically start redirecting traffic until you get to whatever percentage you need and balance it a little better. So that's one thing I would definitely say. The other thing I would bring up in terms of traffic managers, remember, you can't throttle and do quota limiting and rate limiting at the edge. And I would do that when reasonable. The reason I think a lot of people don't implement those kind of traffic management at the edge is because they're afraid of blocking people. And that's reasonable. What I would say is, don't worry about your quota and throttling. Don't worry about tuning them within like a millimeter. Most attacks, whether they're malicious or accidental, like bad code, which we've seen kind of come across as DOS attacks, most of those are big enough that you don't just kind of, they just went over the rate limit. It's, quota's over here, then something goes wrong and it's like, it's orders of magnitude more. So my point in saying that is, for traffic management, like we talked about, feedback, so you can have the edge automatically kind of run around. And two, for traffic quota and or rate limiting, depending on your exact use case, don't worry about getting exactly right. Aim a little bit higher than you think you'll hit, and that can definitely save you from the unwanted stuff. Because what we found in unwanted stuff, aside from maybe impacting your availability and taking your service down, we've seen people actually get massive bills Just because, right, the traffic came in, and if you didn't have any quote or anything, the edge forwarded on very quickly. And then maybe have some auto scaling groups, things spin up, you got a bunch of egress costs, and next thing you know, you've got a really big bill. So those would be the 2 points of traffic management. But I'll pause there because it's one of my topics. Availability and load balancing and SRE is one of my topics, so I won't bore you guys all with my one of my many long tirades.
No worries at all, Pavel. I think that was a really good wealth of information, and thanks a lot for sharing such valuable information with us. So, guys, if you guys want to connect with Pavel and Jonathan, you can connect with them via LinkedIn. LinkedIn, right?
Yes.
Okay. So you guys can connect with them on LinkedIn, and with that in mind, I would give the stage again to John to do the outro. I understand that there were some lag issues, but be rest assured the session will be uploaded on YouTube, so you can rewatch this at your own convenience. So John, over to you.
All right. Well, first, I'd like to say thank you again to Pavel for a great presentation, and Nikhil, thank you again so much for being a host. It's really wonderful to be on with you and to have you get a chance to participate and ask questions as well. And so thank you again to everyone who spent the time. I know we're over by about 10 minutes here, so thank you for everyone who's joined us today. We are going to be back next week talking about criminal economics, which is one of my favorite